Hey, oh, I think we are live. Uh, hey, I think we are live. So what are we going to do? Eh, Okay, so we are going to be doing the CP31 sheet, code forces. I am actually a BTech student doing in computer science engineering, and I'm in second year, and I am not good at it at all. So yeah, we are going to be starting with competitive programming, and for that I'm not going to be doing the code forces or other contests. I will first just build up the base. So I'll start with the 800 rated questions. So the first one is halloumi boxes of CP31 sheet. Okay. And also I don't know C++ yet. So I will learn that along the way. Okay. Theophanous is busy after his last contest, as now he has to deliver many halloumis all over the world. Let's just open our like paint, you know, so that to easily. Yeah, yeah. Okay. Okay. Theophanes is busy all over the world. Each of them inside and boxes, each of them has yeah written on it. He wants to sort them in non-decreasing order based on their number. However, his machine works in a strange way. It can only reverse any subarray of boxes with length at most k. Okay. So his machine can reverse any subarray of boxes with length at most k. Okay, so like, damn, that's bad. I'm just even you do and then E3, E4. Okay, so let's just assume this much, and now it will reverse it. Subarray. Let's just, you know, I know what a subarray is, but I have to refresh my. I don't want to be wrong, basically. So let's search it. Subarray. So inside another array. Okay. And three for one to one. Okay, basically like goes you know, okay, like like set there's set and set subset. Subarray is basically like subset. Sequence is a sequence that can be derived from another sequence by removing zero or more elements without changing the order. Oh, okay. Basically, yeah, remove it. Subarray is contiguous. Sequence is not non-contiguous, but in the same order. And subset is subset. You know what's a subset? Subarray is like a subset. Not what it was, because if it was the bit, then 1 and 4 would also be there. Okay. And if it's possible to sort the boxes using any number of reverses. Okay, so the number of reverses are infinite. Reversing a subarray means choosing two indices I and j and changing the subarray a1 to an to. Okay. Okay, this last line is a bit tough to understand. Reversing a subarray means changing two indices I and j. Okay, that is simple. Two indices. So like if it's 1, 1 and 4, 1 will become 4, 4 will become 1. 4, 3, 2, but I have really bad handwriting. Just horrible, horrible handwriting. Okay. I think now we have some space. Okay. So basically they did this. So yeah, so this much. Okay. So length of the array is then j plus I, j minus I plus 1. Hmm. It's that one. We have 5. Yeah, so my friend told me this. 5 means 5 test cases. One, 2, 3, 4, 5. And the first two are like, you know, first line contains number of test cases. Each test case contains two lines. First line extension contains 20 n and k. Number of box enters, length of maximum reverse that Theophanes can make, and integers. Okay. Contains and integers. And then the number written on each box. 3 is the number of elements in the array, and 2 is how many is like the maximum length of the subarray. So 2 is the maximum length of the subarray. So let's consider this case. Yeah. Let this one off the board. Eraser, eraser, eraser. Right. Oh, there's an easy way to do it. Selecting it and then erasing it all. So let's just, do it in some extra space. A lot of space. We have a lot of space. So, okay. Uh, answer 10. Oh, that is lightest. Very long. That's very much. Okay. 1, 2, and 3. That'll be 1, 2, and 3. Okay, so we can reverse them. And 2 is the maximum length. So we can reverse these two. It will become 1, 3, and 2. Now we can reverse these two. 1, no, not 1, 3, 1, and 2. Now we can do these two. 3, 2, and 1. Once we did this, then we did this, then we did this. Uh, okay, so clearly we can reverse it, but we need to figure out the algorithm that confirms that if we can reverse it or not. We don't have to reverse it. We just, since the answer is yes and no, output is yes and no, we don't have to reverse it. We just have to tell that if it is reversible or not. Let's look at the no case in which we cannot reverse it. Can I do that? No. Then it is. And then delete it. Uh, and let's delete this too. Okay, that was easy. Okay, so 2, 3 and 1, and we can just do it single time. 3 and 1. Oh, I want to do this. thing. What was that? Okay, 3 and 1. If you just reverse it once, I cannot reverse anything. It will just click How can you reverse a single element? It will just stay there. We need at least two. Oh, we have got one condition for the code. There's some notepad like no, yeah, version. It's reversion a word. I'm gonna write mm, J is greater than one. That's the first condition. Now let's try to apply that condition to others so that we know if it works or not. And 3, 8, 34, T. Oh, my bad. And 3, 8, 30, 14. Non-decreasing, increasing order. So, oh, sorry. In the first one, yeah, I did it wrong. Uh, it's 1, 2, 3. So it just needs to be, it does not need to be changed. It's already in increasing order because we're doing non-decreasing, I increasing. Okay. And 9 and 9, you cannot change it. It's already in increasing. Oh, yeah. So let's look at this case first. And because this is like curious, more curious in this. Mm. So in this case, it's the same. All the elements are same. So there is no decreasing, there is no increasing order. And the output is yes. So we have to find a condition for it. A is greater than 1, it does not matter because whatever the value of k is, you still need to give the algorithm the condition to print out yes for this. All the elements are same. So what can be the condition for this? Okay, let's think. 999. Oh, German for no. 999. 9 is German for no. Yeah. So, uh, 999. Just think. Uh, Yeah, now I got how that works because it's the dice, not the number itself. And the dice start from zero, so got it. This one. Okay, so yeah, what can we do it for it? It's nine, nine, and nine. Mm. Oh, yeah, this is a tough one. Okay, so it's a bit, all of them are. Let's check them. I can check for it. Hmm. I didn't even consider how I'm going to be inputting the test cases. So you need to check if they are already sorted such that I can answer that yes, it is can be sorted in non-decreasing order. Do I need to? I mean, I need to because if I just blanketly put the condition of that if only k is greater than 1, then because then it won't work. Because first I have to sort through that, and then the ones that are unsorted, for those I have to put that condition that k needs to be greater than 1. Hmm. Okay, so I think that even if it's too late, I can sort it. But how do I say which is one is sorted already? Okay, I'm gonna lie, I think I'm going to need some help. Let's see it. Solution. Okay, it's not unsorted. Yes. What do I need to check it? Oh, yeah, I don't know that. You might call this cheating. I call this learning. I feel like I'm cheating. But let's not get into it. Long, long, n comma k. N comma k, we know what's n comma k. Hmm. They're just using a function to sort it. Okay. S- I mean, yeah, if you want to check if you have to sort it first. I am really hungry right now.
Now, as you can see, the main function returns an integer, which is a whole number, like. So you have learned how to declare variables and constants. Now let's see how we can write mathematical expressions for performing calculations. This is where the fun begins. So I'm going to declare two variables, x and y. Now we can declare a third variable and set it to x plus y. Here, and is a result of the result is not going to solve this problem because, as I told you earlier, if both our numbers are integers, the result of the division is also going to be an integer. So to get a floating point number, we have to convert one of these numbers to a double. So take a look. First, the warning goes away. Now, if we run our program one more time, look, we get 3.3333. Okay? So this is how division works in C++. Now let me revert this back to integer and integer. Now we have another operator called modulus, which returns the remainder of a thing. Let's say we want to evaluate it x. They are increment and say x equals a way to operator. Or there are two ways. Let me show you the is as a assigned to y1. Let me show you y parity. In this case, x is going to be 11 and y is going to be 10. Now, what if we apply the increment operator as a prefix? So we declare another variable and set it to plus plus x. In this case, because we applied this operator as a prefix, first, the value of x is going to be incremented by 1. So x is going to be 11, and then the result will be stored in z. So in this case, both x and z are going to be 11. Let's verify it. So if we print z, well, in this case, z is 12. I made it. So if we comment our program, there you go. First, this piece of code is going to get evaluated. So first, x is going to be 1. The current value of x, which is 10, is going to be stored in y, and then x is going to be incremented by 1. Hey guys, Mosh here. I hope you have been enjoying this tutorial so far. See concepts. This video to around certificate of the link is what do you think we're going to get? Pause the video and think about it for a second. This piece of 7. So here's what I want you to so and I'm going to run the program. Any operators, always operators. Parenthesis. Here's your z is going to be term and so you have learned how to write to the console or the console. So in the S presents, in programming, a stream represents a sequence of characters. The standard output is our console or terminal window. So using cout, we can write a sequence of characters on the standard output, which is our console window, right? Now, these double left angle brackets are called the stream insertion operator. It's an operator for inserting something to our output stream. In this case, we're going to write a sequence of characters which we specify using double. So we say x into a single statement and then put stream insertion operators. So if we run our program one more time, we get the exact same result. Beautiful. Y equals, and then we add y. Right here was on the second line, new line. So once again, we chain the stream insertion operator. And this time we go in the std namespace and pick up endl, which represents the end of the line. Okay? Now, let's run our program. Modify this code, you can cout. So we get the exact same result. How as well? Modify this code by combining these two statements. So again, we don't need the second cout. So let's remove that and this semicolon as well. Now, if we run our program, we get the exact same result. However, our code is not formatted properly. It's a little bit hard to read this code. So here I'm going to use tabs and spaces to align these operators. So what we have in our code looks exactly like what we expect in the output. Okay, this is better. Now there is a tiny problem in this code. We have a bit of repetition of std double colons. So we have repeated this in two places. Let me show you how to simplify this code. So before our main function, we use the using directive to pick up the std namespace. So here we type namespace std. Now std is defined anywhere in this file, so we don't have to repeat it in multiple places. So we can simply access all objects in the std namespace. So let's remove that and this one as well. And finally, let's realign this bracket. Great. So now our code is cleaner, more concise, and easier to read. Great. Now here's your exercise. Imagine you have a store and you have made $95,000. Now, as part of your tax return, you have to pay state and county tax at different rates. So state tax is 4%, whereas county tax is 2%. Now I want you to write code to show your total sales, as well as your state tax, your county tax, and the total tax you have to pay on this income. So pause the video and work on this exercise for 5 minutes, then come back see my solution.
It's pretty easy. Let's do it. See out. Oh, funny. Reading my screen. It, I just saw it, and it was even suggesting me CT, or maybe a lot of people just do it and they just train it on that. Probably. I'm gonna hope that's the case. I'm just not reading what I'm seeing on the screen. I certainly hope so. What are the issue here? The compile error expression for when complete upload at the end. Eh, I will complete it. Don't worry.
Work on this exercise for 5 minutes, then come back see my solution.
No, let's hope it works. Here it works.
So I'm going to use here we add and from our pros 95. So again, we print this
If it
on the
is
terminal.
printed in double.
So state tags is once again bit of code, run it, make sure. The first thing I want to improve here is formatting. So the first two lines are about the total sales, whereas the second two lines are about the state tax. These are two different stories, right? So here I add a vertical line to separate these stories. Just like how we have multiple paragraphs in an article, we want to write our code so every story is separated from other stories, okay? So here's our state tax. Then I add
Oh,
another vertical line to separate it from the return. Even though it's confusing, someone else reading your code may not know what that number represents. So here we can make our code more expressive by storing this value in a separate variable. So right here. Now it's completely clear what this value represents. I have to call this I call it const keyword. That's better. Change the state tax rate. How can we solve this problem? Now, there is a tiny problem in this code. The problem is that I can accidentally change the state tax rate. How can we solve this problem? Using a constant. So we qualify this with the const keyword. That's better. Now we have to repeat the same 3 lines for our county tax. So I'm going to copy this and paste it. And again, note the vertical line. This is to separate these stories. So over here, we're going to rename this to county tax rate, which is going to be 2%. And over here, nothing new. And we should kind of an abbreviation. So count TR. So we can use abbreviations to quickly type our code and press enter to complete it. Okay. So our county tax is 1900. Beautiful. Now the final part. We declare another variable, county variables code. Next, all right, now let's see how we can read input from the console. Console. Let me show you how. A value. But first, then we use cin and put it action on confusing. So in putting it this way to let's enter a value, let's say 10, and we get 10 in the output. Beautiful. Now, what if we enter a floating point number, a number with a decimal point? Let's see. So this time I'm going to enter 10.1. The decimal part is gone because we declared this value as we have to use x and y. First we read x and then we read y, and finally we can print x plus y. This is using a space, and we use these statements, the stream extraction operator, to read the second value. So look, we start from the console, we read something and put it, but our code exercise, I want you to write a program for converting for Celsius so this is a picture in value and put it in
That's a
this
lame
variable.
program.
The reason I'm so I have this, I'm using cout 0.2 in Celsius.
I'm
So
hungry.
you have seen that the standard library, we're going to look at functions. A file called CMath. This file declares a bunch of useful mathematical functions. Now, if you're curious what these functions are, just go to Google and search for CMath reference. There are many different websites that give you a C++ reference. One of them is c++.com. The other is cppreference.com and so on. So as an example, let's look at this page. So over here, you can see all the functions declared in the CMath library. In this lesson, we're going to look at a couple of them. One of them is ceil, which rounds up a value. The other is floor, which rounds down a value. Now, if you click on any of these functions,
We are in Java too.
you can learn more about
I
it.
mean, of course.
So on the top, you can see different versions of C and C++. So C90 and C99 represent the old C language. C++98 is one of the early versions of C++ that came in year 1998. Then we see how this function has evolved over different versions of C or C++. Now, don't get hung up too much about these details. All I want you to pay attention to here is that this function takes an input of type double and returns another double. So let's see this in action. So back to the code, argument. So we pass 1.2. Now we get a double value that we can store in a variable. So let's declare a variable of type double called result and set it to the return value of the floor function. And then we terminate this statement with a semicolon. Now over here, we say that we are calling the floor function, which means we are executing it. We are giving it a value and getting a new value. Now we can print the result just like before, multiple, and the result is 1. Okay? Now some functions take multiple values or multiple arguments. One of them is the pow or power function. So let's take a look. Comma. So if we say 2, 3, that means 2 to the power of 3. Now, when we type this, CLion adds these labels, LCPP_x and LCPP_y. These are the name of the parameters of this function. If we run this, we get 8. Okay? Now, radius of a circle, and then it should then see a number here, so or equal radius to the power of 2. So our program 50.2 I'm going to cover in this section is comments. We use comments for different ways. Whenever we start with a / and an asterisk, and then press enter. Now CLion automatically generates this block of comment. These two characters represent the line or a multi-line comment. Okay, if you want to have multiple lines, again, more, but then we'll now works. And whatever we type in right hands don't get compiled. Now in C++, we have a couple of different ways for writing comments. We can start with 2 /, and whatever we type in front of these slashes will be considered a comment. Now we can add the slashes above a line or in front of it. Either way works. But as you can see here, we have limited space because we're basically down to what is left here. Of course, we can write a longer comment, but then we'll have to constantly scroll to the left and to the right to see what is going on. So it's more conventional to write the comment above a line. Now, if you want to have multiple lines, again, we can start a new line of comment like this, okay? Now, in C++, we have another way for writing a multi-line comment. Instead of 2 /, we start with a / and an asterisk, and then press enter. Now, CLion automating of the block, what we put in says, that's what we're doing on the next line. So this comment is completely explained certain way. Various types for representing numbers and their differences. You will have a deep understanding. So now C++, its type, and this type cannot change throughout the lifetime of our program. Other examples of statically typed languages are C#, Java, TypeScript, and so on. In contrast to statically typed languages, we have dynamically typed languages like Python, JavaScript, and Ruby. In these languages, we don't have to give our variables a particular type. The type will be determined based on the value that we assign to these variables. And that type can change throughout the lifetime of our program. Okay? So that is the difference between statically and dynamically typed languages. Now, in C++, we have a bunch of different built-in data types. So far, you have only seen int and double, but we have more built-in types that we're going to cover in this section. In this lesson, I'm going to give you a basic overview of these types, but as we go through this section, you'll become more familiar with these types. So for storing whole numbers, we have int, which takes 4 bytes of memory on most systems. This is not a hard and fast rule. Depending on the implementation, the number of bytes taken by an integer can vary from one system to another. But for the most part, you can assume that an integer takes 4 bytes of memory. In 4 bytes, we can store a smaller number. We don't need to waste 4 bytes of memory, so we can use the short type, which takes 2 bytes of memory. And in 2 bytes, we can store the values from minus 32,000 to plus 32,000. Now, for storing larger numbers, long, which takes 8 bytes of memory and allows us to store really large numbers, types, unless you're working on programs that involve complicated mathematical computations. Now, for numbers with decimal places, which we call floating point numbers, we have double, which you have seen so far. The double type takes 8 bytes of memory. Now we also have float, which takes 4 bytes of memory, and long double, which takes 8 bytes of memory as well. Again, most of the time you would be using double, especially for storing monetary values, because the float type can result in loss of accuracy. Now we also have the bool type for storing true and false values. They're often used to represent a condition like, is this person storing C types in with the basic built-in types in C++, let's look at a few different ways to declare and initialize variables. So I'm going to start by declaring a double called price, and we're going to set this to 99.99. Nothing new so far. But what if we want to declare a float? Well, we can declare a float called interest rate, and that is short for float. This is really important because if you don't type this, by default, the compiler will treat this number as a double, and then it will try to store a double inside a float variable. And this can potentially cause data loss. So when working with float values, always type an F at the end. It can be uppercase or lowercase. It doesn't really matter. Now, there is another reason we should type this letter. We'll come back to this shortly. Now, let's declare a long. So long file size. We can set this to 90,000. Now, similar to the float type, here we should add the L suffix, because if we don't type this, the compiler will treat this number as an integer. So to force the compiler to treat this as a long, we type either an uppercase or a lowercase l. Now, the lowercase l can be confused with the number 1, so the best practice is to use a capital L, okay? Now let's declare a variable for storing a character. So we say char letter, and here we use single quotes to represent a character, like A, okay? And we can set it to true or false. These are the acceptable. Example, if we change bool to auto and then hover our mouse over is valid, look, the compiler knows that is valid is of type bool. Similarly, if we change char to auto and look at the type of this variable, we can see it's of type char. Now, here's the interesting part. If we change long to auto, we can see that file size is of type long because we added the letter L at the end. If we don't type this and use the auto keyword, look, file size is treated as an integer. So that is why we need to add this suffix. Similarly, for float, if we use auto, now we can see interest rate is a float, but if we remove the suffix, it will be treated as a double, right? Particularly useful when working. So let me delete all this code and declare an integer called number and set it to 1.2.
I really think I need to end stream right now. I'm getting really hungry. I'll come back and then stream again. solve this halloumi boxes question and then keep it at that for today. Okay. So